To disassemble the radio, we take it out of the belt clip. With a flathead screwdriver on the bottom side, you can kind of pry it open, slowly work it around the edge of it, twist it a little bit to pull the back off. See the battery inside? This one's a BP-11, rated at 1000 milliamp hour, and the FCC label inside of the device. There's a total of 6 screws that we need to remove. These are small Torx. I don't have the bit handy, so I'm just using a small flathead jeweler's type screwdriver. The two in the middle are kind of underneath the label on the edges. You don't have to remove the label, but you can kind of get to them beside the label. You see I've got the 2 middle ones removed or loosened. One came out. One's still stuck in there, but it's loose. I got 2 at the top to take out. And they popped out. I'll probably have to actually take the knob off for the power/volume. But if you need to, it just pops right off. The face of the radio separates now that all the screws are out. But it might be kind of stuck in there, so you got to kind of work your way in beside it. You can see it start to lift open there. We use the edge of the screwdriver. We can kind of get in there and start to pry it out. It's possible that last screw in the very middle there was still hooked up a little bit, and part of the reason it was so hard to get open. So you see 2 wires hanging down for the microphone, and we see the speaker, and they're all potted in there, which is really good because that was part of the IP67 waterproofing that went in there. Up in the top, we've got this little ribbon cable, a piece of tape across the top of it, keep it from opening up. So I'm pushing the little black tongue towards the cable, but this one doesn't actually open that way. If you reach in from the other side and kind of push up, you'll see it kind of hinge up, and that's what releases the cable. The cable's still stuck down inside of there, so I put my screwdriver underneath of the ribbon and pry up gently, and it pulls it out of the connector. It's a pretty good design using the flex circuit as the interface. Here I'm trying to get the board out of the radio, but the combination of it being stuck in the top with the antenna and then the side with the buttons and then stuck up around this flex circuit makes it quite a bit of wiggling to get it out. Just kind of prying it around, trying to get it to separate. Looks like it's finally moving. The antenna pops out of that slot. So you see there's 2 boards. There's a side board with the buttons, and then the main board. The main board has a couple wires coming out to the charging contacts on the side of the body. And here on the bottom, you can see the USB-C port and then the programming port. Higher resolution pictures, we can see some of the microchips that are inside of it. And then this way the sideboard's put on is actually pretty impressive. The BK4819 from Beacon, it looks like, is the half duplex FM transceiver chip capable of operating between 18 and 620 megahertz, or a little bit more than that, specifically designed for the FRS. Actually includes the ability for modem communication. So looks like a pretty capable chip, including the CTCSS, the DCS code. It can actually do DCMF too, it looks like. Dual tone multi-frequency. Probably handles the Vox circuit, the signal strength indicator. Pretty interesting chip. There was an article on Hackaday as well about some mods that were done to the UVK5 around this chip. So it definitely has some history in the mod community. EP2 T45. The only data I can find is that it is used in other devices for the Bluetooth low energy connection, and we can see that probably because it has the antenna built onto the board. I can't find a data sheet for it. It seems very likely proprietary to China. Here's one place that had it, JLC PCB, and they had it for 3.8 cents when they had some reels in. They haven't had reels in quite some time. So on the YouTube channel, Coder Knob Electronics Repair, in his teardown of the TDH3, you see this same chip, the EPT 245 F10E, also used in that radio, but I can't find any more information about it. There's a chip labeled HB, and then it has the full name, HBMW or HBM32G003, and then TS20. And here we see that it's a full 48 megahertz Cortex M0, 64 bytes of flash and 28K of ROM, and 28K of flash on the chip, 2K of RAM, 12-bit, successive approximation A to D, and it has super low sleep state down to 0.6 microamps supposedly. In the place that I found it, it was being used as a motor driver. But again, not a whole lot of information available on this chip. It's just a Cortex M0, it looks like. The H0602C looks like a power amplifier for UHF, VHF. So this is probably the actual final drive for the radio. It says it can run from 1.8 megahertz to a gig. Typical is right inside the FRS radio frequency, and it's capable of up to 2.5 watts out. So they probably have it turned down a little bit for this radio, down to 1 watt. And so we see markings for the chip H0602C, and then below it YYWWSS for year, week, and then subcode or sublot number. So in our case, year 24, week 31, sublot 27 on our chip. the TM1652 is the LED driver controller from, looks like from Titan Microelectronics. This is by SPI. You clock it in and has all the different drives for all your different LEDs. So this is the display driver, effectively. And I don't think this one has the markings listed on the chip. This was translated automatically from Chinese to English, so your mileage may be varied. That's what it looks like in the original. So the original data sheet looks something like this, but I wasn't able to read it, so I converted it with some website, online doctranslator.com. I guess it worked okay. On the back of the board, we have an 8002D chip. And if we look at the English version of that, not sure. It looks like there's several different companies that make versions of this chip. But it looks to be the audio amplifier. If we look close to the wires that go around it, it does indeed look like it's connected to the speaker. And so here it says it can drive up to 5 volts, and in low shutdown, 0.6 microamp draw. Typical output, typical circuit. Block diagram. Got amplifier, staged amplifier, and shutdown pin. 10 microfarad tantalum or electrolytic, so this is probably 8-inch supply stability. So that big giant capacitor in there is probably specific for the audio circuit. Example of metal domes, maybe 4.5 millimeter, something like that. Metal dome switch. It's actually pretty good switches. Don't know who made them, but here's an example of a company that makes metal dome switches. And there's a good chance that what we're looking at is a circle 4 to 6 millimeter, something like that. So this is best technology. It's probably around a 4.5 millimeter. Looks like they're quite available in quite a few different sizes. You can get them by different weights and coatings. Probably just end up being a couple cents a piece, but pretty good switches for just a couple pennies. the cutout, and then they solder it on. A little breakdown of the different functions. So from the manual, we've got the crack and copy method, and if we put the radio on channel 1, turn it off, hold the PTT button all the way down until the radio boots, and then let go. It starts flashing. That means it's in crack mode. And here we're going to actually, we left it on channel 1, so we're going to crack channel 1. So when a radio is transmitting, it beeps when it's done, and it auto increments to the next channel. So it's received the code from that channel. And this seems to only work for the CTCSS tones, not DCS or any of the others. So to copy a radio, which is quite a nice feature, if we put the one that we want to copy from on channel 2, that's the one on the left, and the one that we want to download that radio into, that's the one on the right on channel 3, we can boot both, and then when you release the PTT button on the one on the left, on the transmitter one, it'll start transmitting over to the second radio. When it's done, it beeps, but you have to turn the transmitter off to reset it. And now all the radio modes, everything has been copied over to the other radio. It's not in the manual, but it was in some of the software notes for Chirp that channels 3 and 4 do exactly the same thing as channel 2 and 3 and 4 and 5 do the same. I think it's a typo there. So it's also a wireless copy. Why they put the same function on 2 different channels, I'm not quite sure. So to switch the radio from into Chinese, press the channel plus button and PTT at the same time, turn it on. But it only turns on to Chinese. You can't then turn it to English or turn it off. So once the Chinese voice prompts have been enabled, you'll have to use software. Either it's Odmaster or Chirp or something to turn those voice prompts back off. I find them annoying, so I prefer to have it off. So no matter how much I cycle through, whether I do the PTT and minus or the PTT and plus, you still kind of have that. It's an example of some audio coming in. See how it sounds at different volume levels. If you have the side button set as the NOAA band, you can cycle through and choose 10 or 11 channels of NOAA. I've forgotten left the voice prompts on, so we're still hearing Chinese voice notifications, but you can see my hand around it impacts the reception just slightly. Pressing and hold that side button will return it back to normal mode. In this case, press and hold the top button, turns on Bluetooth. Press and hold that button again, disables Bluetooth. That's what you need to hook in Odmaster. There's an undocumented mode if we hold the plus and minus on any channel and turn the radio on. It'll enable programming mode. It'll time out. And then even if you don't have the Bluetooth set on any of the side keys, it will turn on the Bluetooth so you can connect Odmaster and program the radio. So this is the instructions that actually come with the programming software. That 20 meg download that you'll see later in this video comes with this video, over 15 meg, just to show you how to select the radio. So we'll look at the Odmaster software. This is on the iPhone. It's also available for Android. First, you have to select Connect Bluetooth. It may be just called TID. If you're on Android, here it's called TIDRadio Kit. So select the TIDRadio, that's the top one, and scroll down to the TD-M11 CH-22. Click Read. Then we can read from the device. And up the top, you can go between either channel modes or functions. Functions affect the radio all the time. So the squelch internally can be set between 0 and 9. We can turn the timeout timer off or all the way up to 300 seconds. This is the voice prompt. There's an error in the software. Don't understand why we have transmit codes in there, but you can turn it to English, Chinese, or off. This is where you'd turn the voice prompts off if you don't want them. The battery save mode between off and 1 to 10. The longer it's set, 1 to 10 is higher battery savings, but it'll take longer for the receive to open on the radio. We just passed the Vox, and now we're on the side keys program, so you can program the plus key or the minus key for extra functions when you press and hold them. They can be monitor, scan, Bluetooth, or weather. If on the software we click on channel, the top left there, we can then program the frequency range and all the encode, decode, CTCSS codes for each channel. There's 22 channels in the radio, up to 22. So there's an error in this message on there that says put in a range between 136 and 174 or 400 to 520, and it will not take anything below 400 or over 480. So that's an error in the software there. It's telling you that the radio supports a range it doesn't. So 481, it didn't take. 480, it does take as a frequency. CTCSS codes, these are the frequency ones in hertz, up to 250 or something. And these Ds are DCS, digital coded squelch. And they end in an N or an I, probably for normal or inverted. The transmit power can be set to low or high, so that's probably 0.5 watt or 1 watt. And the bandwidth can be set to wide or narrow. There's a compounder, so that's a compressor, decompressor for the voice to try to get a little bit better quality sounding voice. But both radios need to have that turned on. You can scramble add some type of, obfuscation to your audio. You can do frequency hop or this BCL. I can't remember what that stands for. The scan add at the bottom is if you have a scan enabled. Be able to just go through the scan channels, see if they're active. You can add a channel to the list or not to scan for activity. So we can set each of the channels inside the device, 1 through 22. Here's an example. Channel 10 is set with a CTCSS code of 77. Here's an example. Channel 22 is set with a CTCSS code of 77, but it's a transmit power high. 21 is a digital DCS code. Channel is high power. Channel 20 is a 77 hertz CTCSS low power. Channel 19 is an example of a DCS with low power, digital coded squelch. You see there's an error in the software, that RX frequency. It read something wrong from the radio, and this happens from time to time. The error checking's not the best in Odmaster. It doesn't seem to crash the radio, or you can load the settings back in. So here, clearly this is outside of the normal FRS range, so if you were to use this, you probably wouldn't be licensed for 460. Have to set it back later. So if you triple tap on the top of that screen there, it comes up with this little message box of, I don't know what it says in Chinese, but clearly there are different IPs that it's trying to access for login maybe. And so that was an interesting undocumented mode of Odmaster. And what selecting each of those three options in Chinese where it's trying to send you. So here it was trying to send me to a local 192.168. So if I was probably going to try to set it local. So they didn't really do anything for me, but here's a problem in that when you actually need the software and you go to program your radio, if you don't have connection to the internet, no matter what you do, I can't figure out a way to get Odmaster to connect to the radio. So if your phone is offline, and it won't even come up with, if you can get the list, and then you go to actually read or connect to your radio, it just times out with this error, connect to network, which is super annoying. So if you need to program your radio, it has to have cell phone reception, which is, or Wi-Fi, which is just too bad. So an example, like when we crack a CTCSS code, it doesn't actually put one out of the list. In this case, it was 77, but it interpreted as 76.9. And you'll find that the quote crack, the CTCSS code, is often not an exact match. Sometimes it's close enough to work, and sometimes it's not. If it doesn't beep beep or stop early, you're not going to have a valid code in there. So it's kind of, the CTCSS crack is a little iffy. Here's a quick scan of the manual. If you don't have yours, you can pause it on each screen if you want to read it in more detail. So it's interesting, there's a vol icon on the bottom right of the display. One thing I did not do is look at what voltage in the battery actually is the different icons for it. And here it says the battery came with a 1000 milliamp hour battery. The unit doesn't work. How to fix it is a little not too helpful. How to clean. If we go to the TIDRadio download page and you try to download, it'll ask you to create an account. If you create the account and then enter anything, literally anything, and then click email, it gives you this little code 751268. And then if I paste that over here and click join TIDRadio, it says I was registered successfully. And so now if I go back to the page and I try to download, it successfully downloads the M11-22.zip file. So you're able to download the CPS software without actually creating an account. So inside that file, if we open it up and look at it, is the user manual and an instructional video, another copy of the user manual, different sizes, but they seem to have about the same content, and then this actual TD-M11 CPS software. And then the TD-M11 software. So in it, if we do help about, we see it was made in around 2019, possibly, version 1.0.0.0, some long number. So it actually has the ability to lock the radio with a password. We can set our side keys, same as we can in the Odmaster. Set our side keys. And then if we try to change the frequency range of the radio, it ends up locking us out with a message. Frequency band has been changed, it'll be cleared. Yes, but then when I go to write it to the radio, it says there's a model mistake. If we read from the radio, we get a read complete, and it says we have firmware version 0.9.4. The RX frequencies and TX frequencies seem to be broken into the standard FRS, GMRS channels. If we zero all of these out, and then write that to the radio. Zeroing will remove the frequency, the channel from the radio. And so if I zero all these out except for channel 1, and I write that to the radio, I now have a radio that only has one channel. So if I press up or press down, it's a single channel. So to delete different channels from your radio, just put them as channel 0. We can set the radio as English and write that to the radio. And now when the radio's turned off and turned back on,
turn on the radio.
It now has an English prompt inside. You can set the timeout timer, so that's between 0 and 300 seconds. We can set the Vox level between 1 and 9. We can set the squelch limits. This is a universal radio setting, between 0 and 9. We set the sleep mode, how much battery saver to do. And here we can select different ports. So I'm using an FTDI, actually a Baofeng driver. And one of the issues is, with the prolific chipset is that it defaults with the wrong driver. So if we use a modern driver, 3.9.6, connect that to the radio, we actually see a warning from Windows. Hey, this is a 3.2.0.0. And now when I go back to the radio program, when I select 8, and then I read from the radio, it actually works again. And so then this is from Miclor. This is a little article that was written by John and Jim back in 2019, explaining some of the problems with the prolific chipset. And if we go here, we can get some of the history of the problem. If your Windows will get some of these errors, you can download the 3.2.2 driver here. And so that's one of the ways around a legacy prolific chipset cable not working right. The Chirp has been working to add the TD-M11 into it. So started around November of last year. Got some different versions. And if we look inside of these files, we can see some notes around the protocol and some helpful notes around what the LEDs mean. It's from here that I see the undocumented feature of channels 3 and 5 behave. Channels 2 and 3 can send and receive, and channels 4 and 5 can send and receive. And then this also confirms the turn the unit on with a channel with plus and minus selected at the same time, and then the radio turns into programming mode. So hold the channel plus and channel minus a little bit longer after the radio has turned on. Count to a couple seconds, then let go. Otherwise, it may not fully start the programming mode. From GitHub, we can see the kind of a history of them going through and adding the features for Chirp. Kind of a change log of what they did. You can load a module here and open the TD-M11. Radio has been password protected. It will not allow you to unlock the radio. You'll need to use the CPS software from TIDRadio to clear the password before Chirp will work with it. So one of the interesting things here is we can see the payload that came down from the radio. It's the firmware version. So this is kind of an interesting way to browse through the memory structure. So Chirp remains an option, or is becoming an option to program the radio if Odmaster or the CPS software from TIDRadio is not available. So from the FCC website, if you put in Guangzhou TID for the applicant name, and then scroll down here and change this to 100 for how many to show, we can see the FCC registry of Guangzhou. And we see the 37 records that they've put in. We can see the TD-M11 by clicking detail. So here we see a 24 FBM11. And so we see a bunch of different records that went in. If we look at details on that, and we can see all the different files that were submitted. Here it says they've got a US agent which is, if we go to this fcc-usagent.com, we can see that there is this Tim Payne guy. He's got a LinkedIn profile, and sure enough, it looks like he has been working with TIDRadio as the US representative. So I can't find any record of the TD-M11 being offered any other flavors, but for whatever reason, they registered the TID-M12 and the TID-M13 as equivalent products. And clearly that's not the case now, because we have a POC product that is now the TD-M13 is clearly a completely different radio. The TD-M13 is clearly a completely different product, but for whatever reason, there's a thing on file at the FCC that says it's the equivalent product. So they worked with a group out of Canada, QAI Test Labs, to test the device. And then they flagged the external photos, the test setups, internal photos, user manual are all allowed, but schematic diagram, block diagram, parts list, operational description, and tune-up procedures are all flagged as confidential, and we can't get access to those documents, even though they were required to submit and review when they certified the product with the FCC. So the external photos, we see the belt clip, programming cable, and the little lanyard against metric measurement. Front end view, bottom view, top view, back of the unit, side of the unit, and we see the charging port. It's on the side here. Channel up, channel down, push to talk button. And then on the other side, we've got the mic. This is the Kenwood style, and it can also be used as the programming cable, and but it's mic and keyboard, mic and headset, and push to talk. And then this is the USB-C charging port. We see the FCC label. It's supposed to go inside in the battery pouch, and it's labeled as a 2A4 FBM11 device. And a picture of the battery. Some of the pictures have, I think, a 1500 milliamp hour battery in it, even though it ships with an 1100 milliamp hour battery now. So internal photos. See the same one with the case removed, the 3 contacts for the battery, and then the 6 screws. So 1, 2, 3, 4, 5, 6 screws. The retainer ring for the power on-off switch and the volume selector is underneath, so we have to slide that off. And then we see the unit that was submitted does not have potting around either the microphone or the speaker, but the product now ships with Celastic material as part of the IP67 waterproofing. And you'll see that in the disassembly video, in this video, that there is some attempt at waterproofing the device. So the one that went to the FCC for FCC registration is missing that. Picture of the top with the removal. This is the cover for the It sits on the microphone and external microphone and speaker and push to talk. It's a little piece of plastic sits in here. And then what's been desoldered from this is the actual external charging connections. We can see a black and a red wire here that are no longer soldered to this board that they removed for this picture. This marked the antenna. And the side button, version 1.0. So what's interesting is if we compare the board that was submitted for registration with the FCC, it still is the same sideboard, TD-M11 PTT version 1.0, but the date code's different. And we don't see any significant difference in the board, but it does have a different date code. So now what's shipping in the product is a 2024-12-24, and what they had back then was a 2023-09-22 board inside of it. So here we can see the date code. In the test report, we see a TD-M11 version 1.2, and the version of the board that's shipping now is the version 1.4. So theirs was dated 2023-9/22, and now we're dated 2023-11/30. So something minor has changed since the registration. So here the battery that was submitted to the FCC was labeled as a 1500 milliamp hour battery. So what was submitted in the test reports was a T-20C 1500 milliamp hour battery, but what's shipping with the product now is a BP-11 battery rated at 1000 milliamp hours. So they've cut the battery size significantly. Interestingly enough, they're listing the software version as a 1.0, even though we still have sub 0, 0.9.4 or so that we have listed in the product now. So that's interesting. And the hardware they called version 1.4. The antenna is listed as a 2 decibel, 2 dB gain. And the inseparable is key in being allowed to be certified as a FRS radio. And so even though the battery was stamped as a 1500, the one that made it to the actual SAR test is listed as 1000 milliamp hour. This is a human exposure to EM radiation. And how much is allowed, how much it tested out as. Pretty sophisticated. It looks like they actually used a robot to manipulate the robotic arm to manipulate the unit under test. And then here's all the equipment that they used inside, so we can actually see the robot. This Stably TX60. Some pretty expensive equipment, Agilents, the Roden Schwartz. So hundreds of thousands of dollars worth of equipment to verify this thing's working right. And then because it's broken into 3 different frequency ranges, we see it's locked out to 0.5 watt in the middle there. That's channels 8 through 14. So channels 1 through 7, channels 8 through 14 is locked to 0.5 watt, and 15 to 22 allows up to 1 watt. The radio mounted inside the test fixture. And the headset that it shipped with for testing. They had this phantom liquid thing, looks like a sink, where they tested it in. A little bit more on the RF test. And here somewhere there's a statement that says they always tested it with the battery full, or usually tested it with the battery full. All right, actual test report. So here they chose 3 frequencies to operate it at. That's in the middle of each respective band. So 462.6375, 467.6375, and 462.65 is representative, 3 representative test frequencies for each of the sections. They tested it to 5 different standards. So the FRS, FCC 47 Part 95, and then a couple other test protocols against it. And the GMRS FRS spec. And here again they reiterate that for FRS, the antenna of this device is permanently attached, which is a requirement. And there's no way for an external antenna to be attached. So if you were to remove that antenna and install one with more than 2 dB of gain, you'd be in violation of ERP limits. It's like the test lab was in Shenzhen, and they tested it for nominal temperature 15 to 35 C and have a spec of -20 to 50 C, 20 to 75% humidity, standard pressure, and then here nominal conditions is a DC 3.7 volts, low voltage cutoff, which now we know where they think the low voltage on the battery is 3.15 volts, and it finishes charging at 4.2, which sounds like a pretty standard lithium battery. The equipment that were used to test the device, some key sites of Agilents, some more expensive equipment. So conducted emissions coming through the cables versus radiated emissions, and put it in an anechoic chamber. That's pretty good. Eat sheep. Have not heard of that manufacturer before. Well, we know who made the battery. They're listed. TIDRadio is listed as the manufacturer of the battery. And here they have it labeled as a 1500 milliamp hour battery, even though in the other report we saw it listed as a 1000. So I guess maybe they didn't decide exactly what they were going to ship for a while. They passed all their tests. They tested at 3 different main frequencies. And then they swept the voltage and the temperature. So at a nominal voltage, they swept the temperature from -30 to 50 C across 3 different frequency ranges and looked at the error, part per million error in the frequency. And looks pretty solid. Then they sagged the voltage to minimum, so 3.15 volts, tested that at STP, 20 degrees C, dead on, right in the middle of the band for error. And then they went to max, 4.2 volts, again at STP, dead on. So that would tell me that the bulk of the frequency shift is temperature dependent. But they did a pretty good job of calibrating that. So checking to make sure that we don't have overmodulation, that they're actually staying within their channel limit, and the three different places that it was tested, 3 different frequencies that it was tested using an Agilent spectrum analyzer. It looks like 9.95 kilohertz, and I think they're allowed up to 12 or so. 9.932 and 9.949. So they tested their frequency limit, their bandwidth. Spree submissions, how it all gets added together, how much they're allowed. We put it in this chamber, measure it up, and then add it all together. They give a estimate and then calculate it out. Some of the test equipment's listed as like just little pieces of cable, which is pretty interesting. And here to check for all the harmonics, they scanned it all the way up to 5.5 gigahertz. Still all the way up to 5.5. And then they used a voice simulator, so they modulated the transmitter with 2.5 kilohertz, and then checked to make sure that they're getting. So the 150 kilohertz has a 12.5 kilohertz bandwidth. When 300 hertz cutoff, it looks like the 1000 hertz upper. This is probably to cut out the CTCSS tones, is my guess. So with that, they sweep it, and so with that same one, we look for the emissions. And so to be an FRS device, it has to be locked out, so channels 8 through 14 don't exceed a half a watt, and the other ones can allow up to 2 watts. And here in the test report, they've showed that the device is actually putting out, the effective radiated power is 1 watt on all bands, except for those where it's required to be cut down. And they're right at the limit of half a watt. So good job. Test the modulation. And everything is at 1 watt is within at this test frequency, 462.65. Tested it with 1 watt. And so there's 300 hertz all the way up to 3 kilohertz of voice input. So we see the frequency sweep here And if 100 hertz got put in or 200 hertz got put in, nothing made it out. But starting at 300 hertz, and this would make sense because the CTCSS tones are below 300 megahertz, so there's got to be a filter in there to block that. The chamber that it got put in for testing. And you can see clearly they did not use the antenna that was inside. They installed their own little pigtail for the RF output into this huge attenuator stack. And then we have the user manual attached, which interestingly doesn't have the label inside of it and doesn't have a very good version description of the manual, but they've got the declaration for the human body testing and all of that. So if you didn't know where to get the manual, you can get it from the FCC website. So on the website right now, they're showing the radios for $36 US a piece. The belt clip is $3. Two of the batteries are $13, or you can buy they're labeled as a 1000 milliamp, or you can buy 5 of them for $23. Looks like. And it looks like, according to the FCC, those were built by TIDRadio, which is why we can't find them someplace else. Got the little earbud, or they have a labeled acoustic tube earpiece. So for $2 a piece, or $2.50, I guess, a piece. What's the difference here? Oh, this doesn't have the ear band. I don't know. It's got the wireless charging cable, which is irrelevant for the TD-M11. It has the programming cable, which is the CH340 chipset for $3, or the external microphone for $13, which is insane because that's how much the radio costs, and the radio is about the size of the external mic. So just use the radio. So they are offering the radio in 2 modes, the one for North America, the FRS radio, and the one for Europe, which is the PMR 466. They're the same price. And both are available in these different colors. We've got black, red, yellow, blue, a dark green color, a gray color, and a light green color. And you can see, interestingly enough, they're listing their exact stock amounts: 42, 47, 37, 45, 45, 45, and 73. And the same thing for the PMR: 80, 97, 89, 97, 94, 99, and 94. So it looks like they have a little bit more stock in the European version. If we go to Amazon and look for the TD-M11, currently one of the best prices right now is if you get this bi-color pack, the black and a red one, for $28. So that's $29. So that's $14.50 or so per radio. About the best price they have right now. It comes with the belt clip, programming cable, charge cable, and the charging brick. There's a couple different other packages that they offer. They're starting to offer a charging base that you can plug it into. It's starting to take advantage of that those two contacts on the side of the radio, we can see it. You slip it in here. My guess is that it's just a USB-C plug. Don't know for sure, but it's most likely just a USB-C plug. Oh, it'll charge the battery independent of the base. Quite interesting. Has a little charge indicator, and we don't know how the base is plugged in, but my guess is it's just a USB-C plug on it. So that could be handy. So you can buy just the charging bases themselves, yep, with the USB-C programming brick. 2 of them for $9, so that's $4.50 a piece for those. You can see the plug on the back. One of the other things being offered now is a pack of 6 with a charging base for all 6 at once. Looks like the same plug that's used on like a PlayStation. So it looks like AC in to the base. And just plug straight into US mains. So if you're going to run a fleet of these, that'd be a pretty interesting option to keep everything charged. And it looks like each one has its individual light for charging status. Slide it in, charge it. It's quite expensive. It's about $100 for the 6. So if we look at what is a 6-pack currently costing, so it's only extra $10 for the charging base. It's not too bad. So at $90, that's $15 a piece, so not quite the cheapest, but it's not too bad. Another $10 gets you charging base. Seems like a pretty good deal.